Hello. Hey, how's it going? So, my name's Ben Kuhn. I'm an engineer on the Windows Runtime or Runtime Experience team. I work with Martin Lovell and some of those guys. We built a lot of the infrastructure that makes the Windows Runtime tick on top of the Windows OS. So, I'm here to talk about async, and there's a lot of it in our platform. So, let's get started. So I'm just curious, just quick show of hands. There was a JS, a C#, a C++ talk before this. How many people do we have here that were at the JS talk? How about C++? Sweet. C#? Cool. So I'm going to show a little bit of all of these. I'm going to show a lot of code. I'm a developer. I sit behind a computer every day and write code, and they threw a PowerPoint deck in front of me and told me to come over here and present to you guys, and so I just kept going and threw a bunch of code into my PowerPoint. But before we get to that, I want to talk a little bit about why we did all this async stuff. You've seen a whole bunch of APIs. You've seen the C# work with await maybe. You've seen some of the JavaScript code where you see .then. The Windows runtime has a ton of async, and it has a ton of async so that your applications don't hang. If you get nothing out of this talk, that's what I want you to take away. We did async. We did these async APIs to make APIs, what's the keyword bingo phrase? Fast and fluid. There it is. So there it is. We don't want apps to hang. This isn't our experience that we want. Okay, so that one's a fake one, but I'm actually running this show off of Windows 8, and apparently there have been a few issues with PowerPoint. So if that happens again, that one's not in my slides, and we'll take a minute and switch over. So I want to go through four basic things. The first thing I want to do is I want to talk about what async is in the Windows runtime. You've probably seen it already, but I'll throw a couple quick examples. I'll spend just a couple minutes talking about how our async model helps fix hangs in applications and avoids that experience I just showed. And then I'm going to spend the rest of the time just showing you guys a whole bunch of code so that you guys can go back, take your new tablets, and hammer out some apps and play with it and see what we've done. And then the last thing I'll do is I picked out a couple of tips that'll help keep you guys moving forward and keep you out of trouble. We had a lot of interns. We had a lot of internal developers building apps over the last few months, and I went back through all of our internal email aliases and forums and discussions and picked out the things that people got tripped up the most on, and I'll go through those with you. Okay, so what is an async API? Well, you've probably seen a bunch of them. I'm going to start off with a JavaScript example. So this is an API, opens a file and gives you back a stream. And the key characteristic of an async API that makes it stand out from any other API is that it starts working, gives you back your thread, and then sometime later it calls you back. So there's a .then. You pass it in a callback, in this case function that takes a stream, because the result of the async operation is going to be a stream that accesses the file. And then you can do stuff with the stream, right? So the other thing that's kind of obvious that makes this stand out as an async API is it says async. And that sounds kind of trite, but async's a really important part of our platform. It's really important. We were very careful about how we named everything across the platform. We worked really hard to think about how we use namespaces, how we describe our API names, and one of the things that stood out was we wanted to make the async things easy to spot, easy to use. And so every async API that follows our async pattern says async in the name. Okay, so the other thing about async in the Windows runtime is that there is no async namespace. There's no place where we tuck these things off into a corner. These are APIs that you'll use every day throughout your apps all over the place. So where will you find async? Let me gray out all the areas that you won't find async. So I went through the list of all the APIs that we have today in the build on your machines. And within a Metro-style app, within all of the Windows runtime APIs available, this is where you'll find them. Okay, so that's enough background. How does async fix hangs? So we know that Win32 and the Windows GDI APIs and stuff aren't part of the Windows runtime programming experience. They're not part of the platform. But Windows still works that way. Windows still has a message pump. It still has to keep a UI moving. And when you write code, your code runs on the UI thread typically. So deep down somewhere deep down inside of the UI frameworks that you're all using is something that looks like a classic message pump. It has one job. It has to keep reading messages and dispatching them to the right components. You'll never see this code inside of a Windows Runtime Metro-style app project. But it's important that this message pump keeps running. So the reason that we feel like one of the reasons we have hangs in Windows applications today and why this problem is so hard is in the existing Win32 API, many of the APIs that you guys use in your desktop applications have a very, very variable, highly variable amount of time that they take. So I used to be on the printing team. I spent 7 years working with printers and devices, and so I'm going to pick on that team a little bit. So this is the Get Printer API. This is the classic Win32 API, and where that ... goes, you can put a number. And you put a number in there, and that says what set of data you want to get back about the printer. You call this API, and so does this API, is this fast or slow? Do I need to spin up a thread, put this on a work item, get this off my UI thread, or do I just call it? 99% of the time, it's fast. If the user's printer is sitting off on some other network over a slow network connection, or depending on which data you ask for that printer, that might be a really slow API. It might be a millisecond, or it might be 10 seconds. If you get it wrong, your user experience is tanked. So with the Windows runtime, we said the way we're going to fix this is we said we're going to take every API that runs too long, or every API that potentially runs too long to sit on the UI thread, and we'll do the work for you. We'll get off the UI thread. You tell us where to call your code back, and we'll call you back where you left off. Now, what does potentially long running mean? Well, for the Windows runtime APIs, we said 50 milliseconds. We said if it might take more than 50 milliseconds, we'll make it an async API. And that's how we ended up with it being spread across the platform in all the places where you see it. OK. So that's enough background. Like I said, I'm a developer. I don't like doing all this intro stuff. I want to get to code. So how do we use async? Well, we'll start with kind of the whiteboard version of how an async operation works. You've seen the programming experience maybe a couple of times already. But under the hood, if you were at Martin Lovell's talk earlier, you understand that Windows runtime objects are essentially COM objects, that they follow a lot of the COM rules. There's interfaces underneath there. It's not the way you experience them. It's not the way you use them, but they're leveraging the COM infrastructure. So we start off, we've got some client application. It's running on a thread. And I want to call an async API. So I'm going to call something like open async. I've got a storage file. I make a method call on that. That looks like something I see in my application code for a Metro-style app. Now, what's going to happen is that open async call is going to return to me an operation object. And this operation object represents the task that I want to do. Now, the language projections are usually hiding this from you. But what's going to happen next is I'm done with that file object now. I'm going to deal just with the operation object. And I've set up my callback. And usually the callback is an object. And the language projections are actually promoting that callback, wrapping it up in some way so that that callback actually exposes or is forwarded through some COM interface. Because that operation object is also essentially a COM interface. I'm going to take that object that the language projection built up for me. I'm going to set that as the completed handler for that operation. I'm going to start the operation. And immediately after I start the operation, control comes back to my client. In the meantime, while my client still is free to run, and most of the time what that means is your client will just return back to the UI thread and pick up, your thread will return back to the message pump and will pick up again when this operation completes. This operation is off doing magic. What does magic mean? Well, most of the time it's a thread pool work item that got spun up. But if it's a Windows Runtime API, the system took care of it for you. You don't have to worry. When it's time to actually invoke your callback, the system calls you back, and it's going to, essentially, using the COM infrastructure, pump a message back to your UI thread. And your callback is going to get picked up right back in that same thread. OK, so now that we're past all of the PowerPointy stuff, and I got through that bit, I can put my developer hat on. Can we see this up there? So here's my developer hat. And let's get started with some code. For those that can't see, it says developers, developers, developers. OK, so C++. So I'm starting with C++. And I'm going to show each of the languages just the basic way that you use an async operation. Now, this is the latest version of our C++ compiler, so it's got all of the C++, I believe the official name now is C++ 11 features that you would expect. And it's also got the syntax extensions that we have for the Windows runtime. So I'm going to ref new create a file open picker. I'm going to set the type of files that I want to find. And I call picker pick single file async. It's an async operation, and depending on how you're programming against the Windows runtime, you may not actually deal with the operation object. But here I've chosen to actually take that operation object directly as a result, and I'm going to set it up manually. So in C#, I might have stuck the await keyword there, and then I'll get back the result type. But here I'm going to just deal with the operation object. And what you can see is I'm setting a completed handler. And in this particular example, I wanted to show what's going on where we're actually creating a Windows runtime object. So the C++ language projection includes this, this object called async operation completed handler, and its job is just to wrap up a C++ lambda, or a C++ callback, or a C++ pick your term. And so I've got a C++ lambda here. It takes the operation object as an input parameter, and then I have to call get results on it. Now, we know that the Windows runtime is exception-based, so what happens if this thing fails? Where does the exception point get thrown? It's going to get thrown when I call get results. And then because I'm dealing with the operation directly, and this is an important point, if I'm dealing with the operation object, I have to call start. If I don't call start, nothing happens. OK, so JavaScript has a slightly different model. They took the same pattern that the Windows runtime exposes at kind of the bare interface level, and they wrapped it up in a way that works for JavaScript programmers. So here, what we're seeing is I'm writing some standard JavaScript. I've got a Windows graphics bitmap decoder, and then I create async. And what gets returned from this create async method is a promise, a JavaScript promise. And that promise has all the methods that I just showed you from the C++ side. I could set the completed handler by saying .completed and wire that up. But I can also set the, I can also wrap that up into one nice easy call. I can say .then. You've seen this a bunch of times. Now we've actually seen what the infrastructure is a little bit. So what's actually happening is .then takes a function, and it's going to call that function back when it's done. It's going to, the JavaScript engine is setting a callback handler that gets the results and passes it into my function automatically. The other thing is, just like any other, just like you would expect in JavaScript, because this is a function object, it captures state. You can capture variables from containing scope. So what happens when I start to stack this stuff up? Well, I've got a .then, I've got a .then, I've got a .then. You can see what happens is I end up having this pattern where I start nesting in and nesting in and nesting in. And eventually, I start to have enough parentheses that it turns into something that looks like Lisp. So there's another way I can write this code that also gets the same job done and offers me some other advantages later. So I can take the same approach. I'll start off with the same setup. I'm going to write a pick single file async API. I'm going to write .then. And I'm writing that. I've got a promise now, right? So I'm writing .then against the promise. and it takes in the file item that I got back from the file picker. And then I'm going to call open async on that file object. But now I've done something different here, and you probably haven't seen this up to this point. I'm going to return the promise object. And what's happening here is I return that promise object, and I call .then again. Now, it looks like I returned an object, and then I called it, but I know that that function that I passed that took fi is completing asynchronously. And that .then runs right away as soon as the first .then returns back to this thread. So what's happening here is I can wire up a series of promises in JavaScript right in a row like this and kind of flatten my function out and keep it a little more readable and more manageable. And the JavaScript engine is going to take care of wiring up the promise that comes back later from the async operation to the promise that I wrote .then against the second time, so that these operate in sequence, so that the callbacks finish in sequence. And I can write code that's a little bit more readable that way. Okay, so now we'll go to C# and VB. So these languages have support for a new keyword, await. And await is a nice, simple way to write against the async APIs, because as I write these awaits, they the compiler has first-class support for asynchronous methods. And what this means is the compiler is actually taking this code, and every time I hit an await, it says, okay, well, I got to wait for something to come back before I can continue. And it reorders these into a series of callbacks. It maintains the state across each of these so that I write my code like I like to think, do this, do this, do this, do this. If I try to do a lot of async operations myself, I always lose track of where I'm at. I mean at home, not on my code. And so, so what happens here is this lets me write code the way that I'm used to thinking about code, but it's breaking up my work for me. Now, when I say that the C# compiler has really first-class support, I mean it's really first-class support. If I look at this example here, I've got a for each loop, I've got a local variable, and then I've got an await in the middle of my loop, in the middle of a link query. The compiler can figure out that how to use await in the middle of the link query and get the result. The end of the await returns a result, so I use it any place where I use a value. And then the other thing is, this is in the middle of a loop. There's loop iteration state involved in this operation. The compiler can figure out how to deal with that too. Try writing this without await, with callbacks. It's a very, very hard thing to do. Okay. So up to this point, we've looked at a basic kind of forward sequence of operations. I start an operation, it completes, it calls me back, and then I can close it out. And I didn't really show close up there, but there's a close method. It's a finalization construct, and it can tear down if you need to release a file handle to immediately use it again in some other way, or something like that. So that's my basic forward path. What happens if something goes wrong? So everything up to this point, you may have seen some snippet that looks something like it in one of the other talks. I'm going to start taking it down another level. So error handling. I start my operation. So this is, I'm going to do the same thing here. I've got a picker, I've got a completed, and I've got and I'm going to call f.getResults. And this is C#, but this is the same as the C++ code that I showed earlier in terms of what it actually does. And I said the error gets thrown at f.getResults, right? So I want to actually handle errors in my code. How do I do that? Well, f.getResults is going to be the point where the exception's thrown if this result fails. So let me try this. I'm going to throw a try-catch around the whole thing. Does that work? What do you think? Is that going to catch my exception? No, of course not, right? Whoever calls my callback is going to get the exception, not my code. So this is another point in this example, at least. We can see that there's where the try-catch sorry, there, we can see this is where the try-catch actually covers. Here's where the exception gets thrown. And that's going to go back to whoever calls my completed handler. So with the C# example, I can just stick a wait in there, right? And now, even though my try-catch is around the whole thing, there's two separate methods essentially going on here. The result that comes back from await is going to happen later, but the try-catch handler, the compiler, takes care of putting that around both of them and correctly handling any of the state associated with that. So now let's go to JavaScript. I want to do the same thing in JavaScript. I want to handle my errors in my code. With JavaScript, they have a different model. They don't have a wait. And so with JavaScript, most of the time when you've seen .then called, you saw it take one thing, one function. In fact, you can provide multiple functions, and we'll get to all of them. But the next one in the list, if you stick a comma and another thing on there, is your error handler function. So with this now, let's go back to our earlier example where we had a sequence of JavaScript operations. I called .then, and I said, okay, this is going to hook everything up in order and make these things happen right. But I don't have to actually write comma error handler on every one of these. I can just stick it on the end. And if anything happens in that sequence of events, my error handler gets called. There it is. Okay. So now we've covered the error path. There's one other thing that can happen interesting in an async operation, or at least many async operations. If I've got a long-running operation, there's a possibility that at some point the user or the application decides that this thing is just too long-running. And so I have the option on an async operation to try to cancel it. And cancellation is best effort. If you call cancel on an async operation, the system will try to do the best it can, but maybe the underlying thing can't be stopped, or maybe it's already so close to completion that it finishes before your cancel notification gets in. But there's a method there to cancel. Finally, the one other thing that happens in an async operation, there's a handful of async operations that also support progress. And the metadata in the type system will tell you which ones these are. A good example of it is SMS, the SMS APIs. And if the API supports progress, you may also be able to get partial results. So with the SMS API, you can query for the available SMS messages, and on progress, you can query which messages are already available even before they haven't all finished loading or downloading. So at this point, I want to show some actual code. I did say I was a developer, so let's jump over to Visual Studio. I'm on a machine that's running Windows 8 here, the developer preview build. And we're going to jump over and show. So I've got some XAML code. And I wrote an app. It's a calculator app. And I've started kind of flushing it out with some more sophisticated functionality. It's a little contrived, but whatever. Work with me here. So I've got a button that essentially does Riemann sums on my calculator. If I jump over to the XAML, you can kind of get a glimpse of what the UI looks like. And I'll run this thing in a second. And so let's do that. So I've written, the other thing I wanted to highlight here. This solution, you've heard a couple of times probably that you can write your own libraries that expose Windows runtime style APIs. I've seen some questions on the forum about it already. I've done that here. So I've written a library. I've written it in C#. If I go in here to properties, I've turned this into a Windows runtime library by just specifying in this project, the C# project, that the output type is WinMD. So I've got a library that does some math operations, and I've got some XAML and a UI that does some front end. So let's start this thing running. Maybe. Or not. Bear with me for just 1 second here. I'll try to see if we can do something else to get this to work. How do you guys like the new task manager? Okay, we may be walking through this without live code. So okay, I'm going to give up. What's the definition of insanity? We could try that. Start without debugging. No, apparently we can't. So we'll go through the code anyway. So I've got a routine here, and I've got a method here that basically does Riemann sums. And if we had live code, what I'd show you is that I've set this library up to take intervals. And when I, sorry. Here's the, no, I'm in the, this is the click handler for the app. I'm where I want to be. Oh, I see. Possibly. Let's just try a rebuild. Well, that's going. I've got some text handlers. I'm reading some text fields, parsing them into doubles, passing them to my function, and then I'm going to let that function do some work and then show the result in the text box. So let's see how we're doing. See if we can get it going. No, I think we might just be toast on trying to do this on the output. So I apologize. So I've got this library, and what I'd eventually show you in the XAML is that I'd put in some huge big number into my intervals because, silly me, I made it an int64, and it just takes the computer too long to deal with, 100 billion cycles through whatever function I put into this calculator, and so the UI hangs. And at that point, I go, okay, well, I've got this function, approximate area, and the approximate area function's over here in my library. And how do I make? I said this is a Windows runtime library, right? So one of the things I want to show you is how to actually build this into an async API. And apparently the only way I'm going to be able to demo this is I can get through compile. But we'll get that far. So let's start over here. And the first thing I want to do to show is how do I actually turn this API into an async API? Well, with the C# libraries, the guys over there made it super, super easy. I said this thing returns an operation. So I'm going to have to go to the Windows Foundation namespace and find the right async operation return type that I want for my async operation. In this case, it's, let me zoom this in. In this case, it's an async operation object of type double. You probably haven't seen this in any of the earlier talks, but one of the things we did, even though this is based off of COM and COM interfaces, is we've added a little bit of infrastructure to support a sort of a template or a parameterized type system so that we can have a strongly typed operation object returned from our function so that it, in the language projections and in the metadata, you can see what type you're getting back instead of having some generic cast from object to something useful. So with that, I'm returning an operation object. I'm going to approximate the area async. And And what I'm going to do is the libraries include support for this async info factory object. And this async info factory.create takes a delegate. So I'm just going to call my other function that I had already written, wrap it in an async thing. And now what's going to happen is it's an async method. It's a Windows runtime async method. And it's going to run off on some other thread. Now, the C# libraries take care of what that actually means. In this case, it means a thread pool. So my thing's going to run off on a thread pool. But I've got a complete async API. That's the whole deal. Now, that's not that interesting. I also said that there's ways to do progress and cancellation. So let me show one more method that I wrote, and I gave it a different name, progress approximate area async, just to differentiate it. Progress is not part of our recommended naming scheme. So I'm going to use the same thing. I'm going to use the factory create, and I need to tell it now that the result is type double, and I'm also going to give back progress, and I'm going to give back progress as a percentage. So I'm going to have progress information of type long. And that's actually, uint 32, but I'm in C#. I'll use the C# types, and they match up. Now my delegate that I pass to this create method needs to take two parameters. It takes a cancellation token, which lets me detect in my method if the user wanted to try to cancel my long-running thing. And I take a progress object, and this progress object gives me a method to call so that I can trigger a progress notification to the client code. So now I've got my Riemann sum algorithm. And once I've got, the first example I just showed, I'm just going to wrap my method and call my method. But now that I want to do progress and cancellation, I have to go deeper into the functioning of how my method works. So it's easier to just put the logic together with the cancellation state and such. So here, you can see there's a couple of things I want to highlight in how I got this done. So first thing is this is a really tight loop. I'm doing some hardcore computation, some tough math, right? But it's a really tight loop. It's going to keep calculating my function's value at each position along the iteration. And so even something simple as calling the now.tix function, the classic C# method for getting the current time, is going to be a significant part of my computation cost. So what I really want to do is I only want to report progress every so often, because the UI can't absorb a billion progress operations a second anyway. So as a best practice, I only want it to tick off a progress maybe every 200 milliseconds. That's kind of a good general rate. And I want to measure 200 milliseconds, but I don't want to measure 200 milliseconds and see if I'm at 200 milliseconds every time I come through this really tight loop. So I've backed off how often I check the time, and now I've backed off how often I send progress reports based on the time information I have. And this is also a good, this pace is also maybe, at least in this algorithm, a good pace to check on cancellation. So how do I check on cancellation? Is cancellation requested? It's really straightforward. The autocomplete will get you to the right spot. And then I'll report my progress as a percentage. Two other little best practices in here for a method that reports progress. I've started off progress at 0. If you've got a UI relying on getting that first progress to initialize, it's kind of nice to get the initial state when the operation kicks off. And then I've also put in a progress report 100, because if the last one I had was 70% and clicking along pretty quick, I don't want the UI to sit there. If they've got progress built into their UI, I don't want them to stop at 70% and then show the result over here and have their bar still sitting at 70%. So it makes the app developer's job easy if you kick that 100% into their app, if you're building a Windows runtime style library. Okay, so now I've got a function that actually does what I want it to do with progress and completion. Let's start turning this into a function that actually calls that, my XAML code, to use that to really build up the UI experience that I want. So the first thing I'm going to do is I need to make this a method that uses the new thing. So I've got my autocomplete for my Windows runtime style library. It just works. And so let me put that in there. I'm going to call the new function. And now I can see what's going on. Well, I can't return, now my function's returning an operation object, not a result that I'm looking for as a double. So I'm going to say await. Await didn't highlight. So what's going on here? Well, await can only be used inside of an async method. So I have to actually tell the compiler that I want this to be an async method. And now I'm good. So if I build that, once again, I can show you that it compiled. We'll try this one more time, just for good measure. And I can see that I still don't have an app that I can run. But if I did that, I could see at this point that my UI is still alive, even while this operation is running in the background. So at this point, now we're up to await. We've seen that before. Let's start bringing in some more stuff. So I'm going to do this a little differently now, because at this point now I want to start setting up progress and completion. So I'll skip await. And I'm going to set this up using the operation object. And at this point, this thing would run. But now I've set up a method. I've taken the operation object, I've started it. Well, I forgot something, right? There's no completion handler. So let's drop that in there next. So there's my completion handler. This is doing the same task that the other one did. And I'm calling close. And calling close is optional, but it may cause resource teardown to happen a little faster, may help with your app's performance. And at this point now, I've got the same thing I had with await, but I've written it out long form. So why did I do that? Well, let's go to the next step. Now I want to put progress in here. Here's my progress handler. And you can see, just like you'd have with an event pattern, the event calls you back with the sender. The operation calls me back and provides me the operation object. And it also provides me the piece of data that I provided from my API to say how much progress I made. So in this case, I'm passing in the %. And I'm just overloading my result box here and dumping the % out into the result box. Now the next thing I want to do is handle cancellation. Now I guess I've kind of glossed over something here. You see I didn't give a type to current operation. Here's the definition of it. I put it up in the class because with cancellation I want to keep track of the current operation that's running. So if the user goes off and does something else, I can cancel the right operation object. And I also have a couple of functions set up for that. So I've got a cancel button handler here, and I factored out my do cancel method. So for the cancel method, all I'm going to do is take that operation object, call cancel. Like I said, it's best effort, but you guys just saw the code for my asynchronous method. That cancel operation isn't going to take more than 200 milliseconds. So in users' terms, that's going to be pretty responsive. Okay, so let's get the rest of the code in there for cancel. First thing I want to do, if I've got a button on here that's going to do a lot of long-running work, is if they already started some long-running work, let's cancel what's already running. And then I want to actually show my cancel button. So there's no point in showing that if there's nothing to cancel. The next thing I need to do is when cancellation happens, that cancellation is going to happen in my completed handler. So let me drop in a new version of the completed handler with the cancellation code in it, and we'll walk through that real quick. So here's our new completed handler. I've got the UI code in here now, so as soon as this thing completes, I don't care whether it completed because it completed regularly, it completed canceled, I don't need to show the cancel button anymore. And then the important piece here is I want to know how it completed. Did it complete normally or did it complete canceled? And so now I can take this, this operation object, which is labeled S, get the status from it. And then the async status completed, it's going to tell me completed or canceled. If it completed, I'll take the results and put it into the result text box. If it canceled, I'll put down canceled. If I don't put this check here and call get results, I'll get an exception because I didn't actually get results to display. So with that, I should be in a position where I can build this thing. And if I were really lucky, I'd also be in a position where I could run this thing, but I'm not. The demo gods are not with me today. And so I think I have to stop there with the demo. So let's jump back in. I'm running my PowerPoint on Windows 8. Let's not jump back in there, unless you want to hear the whole thing again. Here we go. OK. So there's how to actually write your own async operation. You can build your own Windows runtime libraries. You can build your own async operations. You can consume them. I've done C# and C# as this combination. Once you build that C# library as a Windows runtime library, you can use the .then syntax against it in JavaScript, or you can go right against it in C++ and consume it that way, because at that point you have a language-independent projection of your functionality. So the 5 top tips that I wanted to pull out of here. We've talked about how COM is underlying a lot of the Windows runtime infrastructure and how these things run essentially as COM objects. We've had a few questions about that. The first tip is don't worry about COM apartments. One of the things that we've done in every language projection is when those completed handlers run, they come back to the same place. So what you do need to think about is whether you're on the UI thread or not. And you only need to think about that if you did something to get you off of the UI thread. If you start using the threading libraries or you start using other things that get you, that you're explicitly saying, go do work somewhere else, then you need to worry about getting back to the UI thread, but not if you're just providing a callback to a Windows runtime object. Second thing, remember to start your operations. So there's a couple of things that trigger your asynchronous operations to run, depending on which language you're in. If you're in C# and you're using the await keyword, when you say open file async, if you don't stick await in front of it, that operation will not begin running. If you're in JavaScript and you call open file async and you don't say .then, that operation won't begin running. You can provide no parameters to it. You can say .then, open parens, close parens. But you have to say .then or it doesn't actually begin working. Finally, if you're using the operation object directly and you're working with that and setting the completed handler and manually hooking everything up, you need to explicitly call start. Third tip, this is kind of a specific one, but this one tripped up a bunch of people. I've just showed you about how cancel works. If I bring up the file picker UI, and then the user in the UI clicks cancel, that doesn't result in an async cancel coming back. That results in a completed with null. Now, the simple thing is use exceptions for exceptional things. That's kind of the simple principle there. And if I put a button on my UI, I better not think it's really exceptional that the user hit cancel. That's not exceptional. But aside from that, that basic principle, it also makes the programming model easier. It means you don't have to actually check the status or do something extra to deal with the cancel case. You say if file, go do the normal thing, else they didn't pick file. It makes the code easier. 4, in your callbacks, you don't need to, especially in XAML, you don't need to worry about dispatch or invoke. Callbacks run on the same thread they're created on. So if you create your callback in a UI thread, that callback gets invoked in a UI thread. That's true of C++, that's true of C# and VB, and that's true in JavaScript. And JavaScript is kind of verboten to say that because all of the code runs on the UI thread unless you use web workers. If you take control of where your code needs to run, like you're using the Windows threading libraries, Windows system threading, then at that point you said, OK, run my code somewhere else, and now I need to pay attention to whether I'm on the UI thread. The last one, don't worry about concurrency. If you're just writing a simple app that is that's not doing any explicit concurrency work, all of your code runs on the UI thread. And that's okay, because all of the expensive stuff, the platform's already moved off of the UI thread for you. And so even if you're doing a long set of really expensive operations using a wait or something, every time you hit one of those slow things, the system gets you off of the UI thread and lets the UI keep ticking over for you. C# and C++ do give you a couple of knobs you can turn if you want to say, you know, I don't want the overhead of coming back to the UI thread to call my callback because I'm worried about performance of this particular piece of my code, so you can run this callback anywhere. If you do that, then you do have to worry about concurrency because you said I want to run my code concurrently. Okay, so that's almost everything I've got. I've got one last one here. So I've got some code up here, and I've got I'm picking a single file, and I've got a button that I want to enable and disable while this is happening. So just quick show of hands here. I'll give you a second to digest, and I'm going to ask you if you think there's a race in this code. Okay, so who thinks there's a race in this code? Who thinks there isn't a race in this code? We're about 50-50, maybe a little bit more think there is a race. This is a little bit of a trick question. If I had written this code today for a desktop application, this would have a race in it. Because as soon as I call start, any number of things could allow another callback to come in if I start pumping messages to my thread. And it's possible that the my button is enabled true could come back in before false happens, before I set it to false. This is a little contrived because it's unlikely the user could actually hit the button that fast, but ignore that for a second. So if in the important point here is in a Metro style app, we've changed the way that the STA apartment works in COM. And we've changed it in a way that prevents other COM callbacks from coming in while you have a COM callback outstanding. In practical terms, what this means is that there's no way for that callback to come in before you get back off of the UI thread in the containing method. What that means is it means writing all this async code for your application is a lot simpler. You don't have to worry about every point where you call a Windows runtime method or a COM method or something else that might actually cause the message pump to tick over one more time. You don't have to worry about those becoming synchronization points in your app where you might have not concurrency, but interleaving of behavior going on. So, yeah. So there's the thing that would be a race. So coming back around full circle, the key thing I want you to walk out of here from, this is kind of like the non-event talk. The Windows runtime makes it easier than it ever was before to write apps for Windows that don't hang. So that's it. Go write some apps. Write some fast, fluid, responsive, great applications. Have fun with the demo machines. And if you want to see more, I've got a list of talks that touch on async. Some of these have already happened. The one talk that I want to highlight, if you want to see more of the C# asynchronous model, Anders Heilsberg will be talking a lot more about it tomorrow morning in future directions for C# and VB. I've got about 10 more minutes left in the room, so if you have any questions, I'm going to say come on up here and we'll go through it.